I'm going to kick off today's keynote session with a quick overview of Airflow 3. After that, we're going to have the different tech leads speak about the key features in Airflow 3 with demos of the critical elements. I'm Vikram Koka, the Chief Strategy Officer at Astronomer, and I've been contributing to Apache Airflow since 2019, and I'm on the Airflow PMC. My contributions to Airflow have been primarily in the architecture and program management front, beginning with Scheduler HA, which we released as part of Airflow 2.0. Since then, I've contributed to features such as data awareness, data-driven scheduling, and most recently, the architecture and program management for Airflow 3. About a year and 3 weeks ago, we announced our goals for Airflow 3, and I stood in front of a lot of you talking about our somewhat audacious timeline for releasing Airflow 3. At that point, we had all the AIPs defined, we had some early designs, and we had lots of POCs, which were showcased in last year's Airflow Summit. But the release was a very long way away. With the work of a dedicated community, we released Airflow 3 on April 22nd, earlier this year, and this was truly an absolutely worldwide effort. We had over 300 people contribute from around the world. We had a relatively insane development velocity of over 500 commits a month, focused on about 13 different PRs, 13 different AIPs. And I could not be more excited by the adoption, which we've already seen with Airflow 3. It is already the third most downloaded version of Airflow. And I'm actually completely delighted with how we actually came together as a community. I think some of the words used were like we're rebuilding the plane while flying it and things like that. Again, this was like a huge effort, and I'm absolutely delighted that we could make this happen. But what does this mean for you as a user? Our focus with Airflow 3 was on 3 key themes. The first one was better user experience. All of the features in the user experience bucket really were driven by community feedback. And the first one, tag versioning, was without a doubt the #1 requested feature from the community for about 3 years running. Tag versioning, which enables historical views of tags, including all the operational information for those prior DAG runs, is part of Airflow 3. A second big jump was a completely rewritten UI based on React. And this is also part of 3. And I'm actually really excited about how the UI has come together. It's really cool. And being able to see the fact that you can actually look at the UI through the traditional task-driven view, as well as be able to seamlessly transition towards an asset-based view, is actually something which I found very useful, and I've heard a lot of people compliment the Airflow UI in this particular aspect. The third key thing in the user interface bucket was really backfills, and probably the single biggest area of questions I got during the beta period. Backfills originally was a bolt-on feature in Airflow, and with Airflow 3, this is completely integrated into the Airflow scheduler and is available through the UI and the API natively. Backfills is a critical operation for MLOps, and we're really happy that we could actually make this into Airflow 3 as well. The second key theme was really driven by the request for task isolation and stronger enterprise security. This drove us towards updating the Airflow architecture with probably the biggest architectural update since the original inception of Airflow. We actually introduced something which we call the task execution interface. We split the Airflow distribution into a client, which we call the task SDK, and the server, which is what we're calling Airflow Core, which includes the scheduler, the web server, the DAG file processor, and so on and so forth. This change and this update is part of Airflow 3, and this in turn enables a whole bunch of new capabilities, which leads to the third theme, which is my personal favorite, of being able to run tasks anywhere, at any time, and in any language. This also builds on top of the updated data assets framework, And this enables one of the most popular features in Airflow 3, event-driven scheduling. I'm really excited by all the changes which we delivered as Airflow 3.0, but we didn't stop there. Airflow 3.1 continued this accelerated pace of development. Honestly, we were very surprised by this. We had about 1,400 commits into Airflow 3.1 in about 2.5 months of development after we released Airflow 3. This is contributed by over 163 developers from around the world. And the only thing I can say is that the development of Airflow has not stopped with 3. It is continuously accelerating with 3.1 as well, which is both scary and terrifying at the same time when we're actually trying to cut releases. And I know that the release managers were definitely in a state of sheer shock at saying, how many things are we actually merging in at this point in time? But it's exciting times as well. What does this translate to you as a user? What does 3.1 bring? 3.1 continues the trend of improved user experience. The fact that the Airflow UI is now based on React has driven a lot of contributions into the Airflow UI. There's been a rapid pace of new improvements to the UX, not only with UI plugins, which was a highlight feature which we absolutely wanted to get in, but also with respect to calendar views and many more, which Brent and Pierre will showcase in just a bit. The thing which was unexpected, which I'm really pleased by, is that the Airflow UI is now completely internationalized. We have translations into 17 different languages, including European languages such as Polish, German, and Spanish, but also languages around the world from Chinese and Hindi and Arabic and so on and so forth. It's amazing how quickly these things have come together, and I could not be more proud of the team for delivering on this. The second key element is expanded integrations. With 3.0, event-driven scheduling was released with support for AWS SQS. With 3.1, again, through the contributions from a really large community, this is expanded to Apache Kafka, Redis, Azure is in the works, and many more still kind of continuing on as well. We have consistently been extending the authoring experience as well with Airflow 3.1. Deadline alerts is part of Airflow 3.1. This replaces SLA callbacks, which was in 2.x, and again improves the DAG authoring experience. One of my personal favorites in 3.1 is what we've been able to do to enable AI workflows. Our focus in 3.1 was on improved inference execution and human in the loop. In enterprise AI workflows, it is very common to have a 4-step process. The first step is gathering all the relevant data together, which is needed by the AI model to actually process and compute what is needed. The second step is passing this relevant data into the AI model to actually get an answer. The third step, typically, is to evaluate this answer computed by the first AI model. And this is typically given to a second AI model to evaluate this answer to say, hey, does this basically meet the criteria which is needed as a response? This is also sometimes called AI as a judge. Based on the scoring of this AI judge, this can then be sent over to a human, which is why it's called human in the loop, to validate this answer before sending it over to the end user. This 4-step process for an AI workflow, which is very typical for AI workflows in the enterprise, is now completely supported by Airflow, and I could not be more excited by this. Now, just stepping back and looking at the overall timeline of Airflow. Airflow has been around for about 11 years, originally created by Maxime, sitting over there in 2014, and we talked about AI Airflow's inception then. There's a lot of work done by Bulka and team about 2018, 2019 in making this an Airflow top-level project. Bulka sitting in the back over there. A huge amount of work to make that happen. My involvement, along with the rest of the Astronomer team, was really in 2019 and 2020, wherein we worked on Scheduler HA, making Airflow enterprise production ready. Ash and Kaxil worked on the Scheduler HA part, as well as DAG serialization. Jarek, Tomek, and Kamil actually worked on the REST API, and our focus then was really making Airflow enterprise ready. Over the next 4 years, we had 11 releases of Airflow, generally been very consistent and very focused on semantic versioning. Our focus was primarily on 2 dimensions, making Airflow a lot easier to use and run, and then on expanding and creating higher level abstractions for authoring. A key example of this was data awareness, starting with dynamic task mapping, data sets, data-driven scheduling, and so on and so forth. With Airflow 3.0 was definitely the biggest release in Airflow's history since 1.0, and Airflow 3.1 is a huge jump as well. And you're seeing this consistent theme kind of growing, and I could not be more excited about the progress which we made over the last 10 years as a community in making all this happen. But where is this heading? How do the features come together, and what personas are we supporting as part of Airflow going forward, and how does this come together? For that, let's look at the survey. One question before we kind of look at the survey results: how many of you filled out the survey in 2024? It was roughly about the same time last year. Definitely a minority. I would definitely request everyone else to fill out the Airflow survey, please. We do take the results of this very seriously. Last year's survey, which was conducted at the end of 2024, had about 5,000 responses from 116 countries worldwide, and it was the biggest data engineering survey ever. There's one particular area which I found extremely insightful. What were people using Airflow for? It's obviously no surprise that the majority of people use Airflow for ETL and ELT. That's over 2/3. But there's a significant number of people also using Airflow for MLOps and starting to use Airflow for generative AI. Remember, this was a year ago. And when we look at people with greater experience with Airflow, those numbers go up quite significantly as well, wherein we see that 1/3 of people use Airflow for MLOps, and about 13% at the end of last year were already using Airflow for generative AI. This then led us towards an updated thinking of who Airflow was for. And it is now our key belief that Airflow is a core technology platform for a growing set of engineering personas, beginning with data engineers, but also expanding to ML engineers and AI engineers. We are also seeing that these personas and the use cases being used by these personas are converging. And that is not just with Airflow, but overall in the ecosystem as well. And that's been one of the key things where, as we think about new features, how are we focused on making the lives of these personas easier, and also continue to expand how we focus on Airflow's reach for these particular sets of use cases. And this is also true based on just the summit. Around 1/3 of all the use cases in this year's Airflow Summit over the next 3 days are about people talking about using Airflow for AI. This not only includes the foundational AI research companies such as OpenAI and Anthropic. Ping has got a talk about how they're using Airflow at scale within OpenAI. Gurmeet and Kushal are talking about how they use Airflow and how they ensure high data quality within their pipelines at Anthropic. But we're also seeing this with a variety of other companies across verticals. Sagar from SAP is talking about how Airflow powers their Copilot. There is folks from, I think Shelvik from Red Hat is talking about how Airflow powers their digital workers. The folks from Financial Times about using Airflow for investigative journalism. Kaiser Permanente about how Airflow is powering their research into medical research pipelines using generative AI. Pinterest, which has been doing a bunch of leading edge work in semantic modeling and generative AI, is talking about how they're using generative AI for even running Airflow. I think Rachel is talking about it. Bell from Duolingo is talking about generating lessons using generative AI. Again, basically being orchestrated by Airflow, and so on and so forth. There's many other talks, but this is just a representative sample of how we are consistently seeing AI workflows as well being driven and supported by Airflow in this year's Airflow Summit as well, which is very, very exciting to see. Now, how do we look at it? When you look at the Airflow ecosystem, prior to Airflow 3, we tend to look at it as being most people interact with Airflow through the UI, through the CLI, and they write tags, they operate tags, they run tags. The data, which is actually being integrated and powered by Airflow, comes from data warehouses such as Snowflake, Redshift, Databricks, and so on and so forth. All the big cloud providers, you can aggregate data, go across multiple different clouds. That's one of the things Airflow does really well, is the multi-cloud and hybrid cloud support. You can actually orchestrate services from foundational models, whether it's OpenAI or Anthropic and so on and so forth, and bring this all together. One of the changes which we believe we made as part of Airflow 3 is with the support for inference execution from the APIs, with the support for UI plugins. Airflow is now being used as a platform for products and services built on top of Airflow itself. In a couple of days, we're going to hear on the keynote from Weave. They're a company, generative AI company. Their product is an AI Copilot for the insurance industry, which is built on top of Airflow. Their customers there don't actually know it's actually using Airflow, but it's a complete product built on top of Airflow and runs on all three clouds. This is a pattern which we're seeing in multiple other situations, but it is worth calling out that as the technology becomes more and more horizontal, people start building services and products on top of it, and that's really what's happening with Airflow today. And that is one of the use cases which we think about making things available to the API and for these particular reasons. A second key jump, which we're actually making now with human in the loop, is for the first time, we're actually having business users coming to interact with Airflow. Somebody approving an AI transaction, right? They're somebody who's focused on the domain. They understand the domain. They might be an insurance underwriter. There might be somebody else who understands the domain. They absolutely are not expected to know what a DAG is. They're absolutely not expected to run, trigger, or operate a DAG. Their businesses are coming in to use Airflow for those particular operations without needing to know anything about data engineering or DAGs at all, which is, again, a very exciting jump from a range of personas which we think about for Airflow. And that's part of the reason why I think the user experience within Airflow now is more segmented than it ever has been in its past. The third key jump which we're making is with the introduction of event-driven scheduling. Airflow now has the ability to react to events in the larger data ecosystem, including streaming applications. When Vincent does his demo, you'll actually see how event-driven scheduling how Airflow can be triggered based on an event coming in from Kafka, and then also subsequently publish events to Kafka as well. And this is how Airflow fits into the broader data ecosystem as well. And with the introduction of Flask SDKs or support for other languages, not just Python, it makes it far easier to integrate Airflow natively into enterprise applications without needing a lot of boilerplate or glue code to make this happen. Could not be more excited about the expanded ecosystem, which we now see with the introduction of Airflow 3 by the scope of releases over the last year. And now, to kind of start the deep dive and demo part of the session, I'm going to hand this off to the team which did the UX features with Jed, Daniel Standish, Pierre, and Brent. Thank you.
Thank you, Vikram. Hi, guys. My name is Pierre. I am a staff software engineer at Astronomer and also a PMC member of the Apache Airflow project. So now we mentioned what new UX features came in with Airflow 3, but before this, I want to give you some context. For Airflow 3, we entirely rebuilt the API and the UI. For the backend, we chose Fast API, and for the UI, React with Vite. I want to thank our amazing community, which made this possible, because this represented a huge effort, and we saw an impressive involvement from our contributors and some companies. So thank you guys for this. Completing this work has enabled new opportunities, and I will mention a few of them here. So for the backend, we now have a much easier to maintain code base. We removed some dependencies such as Flask App Builder and Connection, which were holding us back. We now have a code-first API design in opposition to spec-first in the past, and this will remove drift between the code and the spec, which was a pain point in Airflow 2. And we, of course, inherit all the fast API features, such as automatic documentation, data validation, and native asynchronous support. For this part, we aim to have a fully asynchronous API server in the near future. This will allow to increase resource efficiency. For the UI, we now have a single-page application, a responsive one. We leverage the great ecosystem of React. This is the community, tools, and packages. Since we switched to a full React UI, we have seen a big increase in the contributions, and this has really benefited the project. We also have a more flexible deployment, since you can now build and deploy your front-end assets separately from the backend. And this has also opened opportunities for internationalization, as Vikram mentioned, as well as more complex features that we will demonstrate in the next few slides.
Thanks, Pierre. Hey, guys, I'm Brent. I work at Astronomer, if you couldn't tell by the shirt. And yeah, all of those changing over to React and now allowing us to have much more fine-grained control over your Airflow UI experience has led to, and as well as like some LLM tools, has led it to a massive increase in contributions to Airflow. So I'm going to demo the UI, but I do want to thank the entire community here. A whole bunch of you have been able to contribute to the UI, which I'm really excited by because it's been able to customize to your use cases. So the first thing we've done is a new homepage, a new dashboard page. So here is your homepage for Airflow. Starting from the top, we have quick stats on how many DAG import errors I have. How many DAGs have the most recent one was a failure. How many DAGs are active? We go down, a recent community contribution is favorite DAGs. You're on a team with 1,500 DAGs in your deployment. You only care about 2 of them from your use case. As well as then further down, you can see quick stats on your DAG process, your scheduler. Are all those things running? And all of this is to meant, where should I dive into Airflow? Next up, we've updated the interface for the DAG page. So one big challenge we had was having your like visualization of a grid, a graph, or whatever, and showing your information. So as we jump into this DAG, we can switch between your grid, a graph, and still have your task logs. No matter what visualization you prefer to see that DAG in, we can even add in the Gantt chart, and we still have your task logs, your render templates, your XComs. So really balancing out visualization, but the critical information you need to debug what is going on in my DAG. The next thing we've done is taking that same interface over to the assets. So here we have a graph. We're going to go over into an asset from our homepage, and we can see that it will have a graph between the DAGs and assets and see how everything is connected. I can go into a single task, see what the events are upstream and downstream in a graph, and then go over to the downstream asset and see what those events were, what did update. Yeah, we've added support for 17 languages with PRs to add in. Greek and Thai open right now, so maybe I should update this to 19 soon. And you can switch over, make Airflow work whichever way you need, including right-to-left support for languages like Arabic and Hebrew. And just really exciting that this is a representation of how international Airflow is, not just people using it in many different countries, but contributing to Airflow from all the different countries where everyone is. Finally, or not finally yet, We've also added a few new visualizations in 3.1, such as the calendar view. So this is a really complicated schedule. A great way to visualize it is seeing it across a calendar on, let's say, an hourly time frame here. And I can toggle between showing just total runs, how much is this like DAG running, or go over to failures, like where are patterns of failures. And I can also switch over to a more daily view, more similar to GitHub contributions, and see trends over months or years. And then finally, this is the actual finally, we've added a whole bunch of new UX for filters. Let's go over into our audit log, and I'm going to look up, I want to find triggered events by a certain user. And so really quick, can add in these two filters on. I can edit my table, get rid of columns I don't care about, and even expand all the information to see the extra JSON. Let's say, what was it triggered with? And just all of these are to get you your information as quickly as possible. And I'll hand it back to Pierre.
Thank you, Brent. With this brand new API and UI, what about plugins? Plugins are a very widely used feature in the community, and I'm super happy to show you what we came up with in Airflow 3. So the first thing I want to mention is that we have a backward compatibility layer for Airflow 2 plugins in Airflow 3. It means that you don't have to do anything if you actually want to upgrade. You only have to install the fab provider. And then but eventually you want to use the Airflow 3 interface because, as you will see, it is much more powerful. For the backend, you can extend the API server thanks to the powerful Fast API interface via sub-applications and middlewares. And this will allow you, for instance, to add new endpoints, inject custom scripts, modify headers, or do processing before or after requests. For the UI, you can extend it by adding external views and React apps. And this will allow you to embed external links, iframes, or full React applications inside the UI. Now, in the following slides, I will show you what it looks like for UI plugins. First of all, iframes. So here you will see on the left in the navbar a new menu item, plugins, where you will find all your installed plugins here. And the first one is an iframe. This will simply render your external resource in a dedicated page, and this is useful if you want, for instance, to embed an existing dashboarding tool or a documentation website. Next step is external link. As you will see here, the second menu item, which is Apache one, is an external link. You have a small icon on the right to make the difference. And this is a super simple plugin that will simply redirect you to an external resource in a new tab. Finally, the most powerful option is to build your own custom React app. Here we put that under a submenu item, and this particular application was bootstrapped with our bootstrapping tool that we provide to help you guys get started with React plugins. And this is what you get right outside the box. It's a simple one, but you can customize it to be as complex as you want. And also, I want to mention that for now, we just demo the navbar plugins, but you actually can target other destinations. Here in the dashboard, you have a React application plugin in the header and another one as a footer. You can check the documentation. There are plenty of other destinations supported, such as the task instance, tagline, or DAG overview pages, and we plan on adding more features there. Key takeaways for plugins is that Airflow 2 plugins are still supported. It is not a blocker to upgrade to Airflow 3. The interface is much more flexible. It can go from a very simple external link to a super complex React application. And some people from the community have already embedded playable versions of the Snake game or Doom inside the Airflow UI, which is pretty cool. And I can't wait to see what the community will build on top of this interface. Now I will leave it up to Jed to present by versioning.
Thanks, Pierre. Hi, I'm Jed. I also work at Astronomer. I'm also a committer and project management committee member. So here to talk about DAG versioning. As Vikram mentioned earlier, DAG versioning was the most requested feature on multiple community surveys. So really happy to say it's finally here. We tackled a couple aspects of versioning here. For execution, we now are able to use a specific version of DAG code for a task. And then in the UI, we handle real world DAGs that do change over time, and we show what actually happened in that DAG run. Simply, we keep history. So that brings us to DAG bundles. What is a DAG bundle? It's a collection of DAGs and other files. The other files bit is important because real DAGs use other files sometimes, right? Say a YAML config file or a SQL file. It's important that we version all of those together. Of course, not every bundle can or should be versioned though. Think local development. And so Airflow supports and handles both options gracefully. This unlocks being able to run tasks using a specific version of the DAG code. And this also means that we're able to run the same code across the whole DAG run. We also support getting DAGs from many different sources. There is not a requirement that you version all of your DAGs together. Combined, this is a huge change for Airflow. It means that Airflow can go get DAG code itself, a specific version of it even, from many different sources. So now when we talk about the UI side of things, it's important to note that we actually track the parsed version of the DAG, not the DAG code itself. And this means that we can show the history portion regardless of your bundle type. And now we'll get into the demo. So we have a very simple DAG here that does a quick sleep and then prints a greeting for us. What we'll do is we're going to kick off a run. I'm going to go out and change the code. Airflow is going to see that new code, and then we're going to make sure that it, ran the right version of our greeting task. So let's get into that. So here's that DAG I was mentioning. We have a sleep, and we say, hello, Airflow Summit. I'm going to go ahead and go out and trigger it. Yep, there we go, trigger. Okay, so now we're going to go out into our editor here. We're going to make a couple changes. First, I'm going to change the sleep so that it's a little faster. No one likes to wait. And then we're also going to say, hello, Seattle, instead of Airflow Summit. We'll go ahead and get this saved and deployed. Oh, sorry. We're also going to change the task ID to show some of the UI history features. Get this deployed. Hop back over to Airflow. Now, if we go back to the DAG, we're going to go look at the code here. And I think it takes a refresh or two for Airflow to see the change, but it will. There we go. And note that first DAG run is still running. Also see the grid now shows, hey, we have hello new and hello. We'll kick off another run. And then before we start here, look at the grid view, right? We actually have both tasks, hello, hello new. Gantt shows the right tasks for the selected DAG run, which is cool. Now let's go look at what we got in our output here for hello. Great, we have hello Airflow Summit. That means even though that run had not finished by the time we saw that change, it ran on the right code. And then here we say hello Seattle. So we have the right version of the task logs. It ran the right code. And with that, I will hand it off to Daniel.
Okay, so for those who might not be familiar, the backfill feature in Airflow is about, it allows you to rerun tasks over historical dates. And some common reasons why you might need to do this include correcting bad data, doing initial loads on new pipelines, and doing data migrations, among other things. So in Airflow 2, backfill was a CLI-only feature. And this meant that not only did you have to use the command line in order to trigger a backfill, that the entire backfill job was orchestrated synchronously from within the command line process. And this made backfills somewhat less reliable than a normally orchestrated DAG or a normally orchestrated DAG run, but it also made the feature less accessible.
So when thinking about Airflow 3, we knew we wanted to make backfills easier to run and observe for users. And we wanted to give users more control over how backfills are run. And certainly we knew that users wanted to be able to use the web UI and the API to manage their backfills in addition to the command line. So in Airflow 3, now this is all possible. We ripped out the command line backfill scheduler, and we gave the responsibility to the core Airflow scheduler for orchestrating backfills. And then we did the work of ensuring that there was feature parity across the UI, the API, and the command line. And the result is a backfill feature that's easier to use and more accessible for people. So now we'll take a look at a little demo of what backfill looks like in Airflow 3. So to trigger a backfill, we go to the DAG page and hit that Trigger DAG button. And now you see there's a new backfill mode for this DAG triggering. And we fill out our date range, and this determines the DAG runs that will be part of this backfill job. And in this case, all of the runs in this range are successful. So to get them to reprocess, we have to tell Airflow to reprocess all runs. Then I'll draw your attention to the max active runs setting. This is a new feature in Airflow 3, and it allows you to pace out your backfill jobs. And this can help you avoid, for example, crowding out your production jobs with your backfills. So we can see now that there's 2 active runs at a time. And if we want to pause the backfill, we can, and it won't activate any new runs. When we're ready to resume the backfill, we can do so. And the backfill will complete. And that's it. So to wrap it up, in Airflow 3, backfills are easier to use, and we have more control over how they run. And we now have feature parity across all the 3 user interfaces, UI, API, and CLI. And with that, we'll hand it over to Kaxil to talk about running tasks anywhere.
Thank you, Daniel. Hi, I'm Kaxil Naik, the Airflow committer and PMC member, and I also work at Astronomer as a senior director of engineering. I have with me Amogh Desai, who is also an Airflow committer and PMC member and works with me at Astronomer as a senior software engineer. So, before we talk about task isolation, let's talk about a story. 1st of October 2025, 6 days back, a new engineer joins the data team. He learned something that all of us do know, Airflow. So he starts learning Airflow. He creates a bunch of DAGs, starts experimenting with them, creates tons of connections and variables. What next? It's almost the end of the week, and they say, okay, I've created so many connections, so many variables, so many DAGs, I should do some cleanup so that the next week when I start and do the experimentation again, I have a clean slate, at least my end. So they ask something that we use almost on a daily basis, at least I use it on a daily basis, an AI assistant. So in this case, for them, it was Cursor. So they asked Cursor, hey, I've been generating a lot of connections. Please help me clean my Snowflake connections on a daily basis. So when I try it out next week, I don't have to worry about that. Cursor will oblige. So there you go. It writes a bunch of code, generates a bunch of code. The code generally looks good. Good ORM, cleanish code. Logic seems sound. Look at it carefully. Logic is sound, right? Well, it deleted 25 Snowflake connections. At this point, they're still like, maybe I did create 25 connections. Until they see this message. Like, oh, damn, what did I do? So it's like, well, I should have not done that. In this case, though, like the code generated was not bad. It was using it semi-correctly, right? But the problem was the context. So let's back up a little bit. In Airflow 2, we documented our security model, which says that every DAG, and so every DAG author has access to the Airflow metadatabase, full access to the Airflow metadatabase, and a remote, like you can execute any arbitrary code in your workers. You think this is dangerous, but no, it's by design. And we recommend it in the documentation that as long as you follow good CI/CD practices, this is fine. Especially at least the review part of the CI/CD should be done. However, we all know what happens in practice, right? When velocity is a priority, who cares about good practices? Things slip by, things fail. Humans make mistakes. AI surely does. So things can slip by, even though all of this was documented. So we said, okay, in this case, at least in this story, the person tried to do something they thought was good and still failed. So Airflow 2 placed a lot of trust on the DAG authors and on the data practitioners to ensure that there are good CI/CD practices. But this trust can sometimes fail, like you saw, fail in more dangerous ways. So Amogh, do you want to show us?
Right. So yeah, just to start off, thanks Kaxil. And yeah, just to be clear here, Airflow 2 placed a lot of trust on DAG authors to be secure, and direct database access was a deliberate design choice that served the community well for many, many years. But as enterprises evolved, and with things like SOC 2 audits and shared complex deployments coming in, this particular trust model started threatening some pillars which every enterprise swears by. So that's security, compliance, performance, and operations. You already mentioned the story about security, so let's talk compliance. You can see that there are no audit logs here. And when you run a task very similar to what Kaxil ran, you will not have any audit logs. And now editors usually ask their favorite question, right? Who touched my data? But with direct DB access, there is no audit trail. And now because of this problem, Airflow, when you run direct tasks in your query, Airflow has no way to see or attribute what runs inside user task because it is not task aware. Now, due to these problems, enterprises obviously find it really hard to certify SOC 2 or HIPAA. So coming to the next two pillars, which is performance and operations, let's go back to the days of Airflow 1.x and 2.x. I think many of you are familiar with maintenance tags, right? Back in these days, companies like Clairvoyant had their maintenance tags, which many or most of the Airflow practitioners recommended using, and teams would often schedule these tags to clean up their database, and it would vacuum and clean like millions of rows. Now, the funny part here is this was a CLI command, which many of you will be familiar with. This is something that people usually run to run these maintenance tags, but humans are definitely prone to errors. So let's say you have a person in your team who ran it with this instead. It's this one, yeah. What do you think will happen? So this indicates the DAG to clean all the rows that are older than 0 days. That's a silly truthy statement, right? So this will just indicate the DAG to do that, and the DAG it'll do what you're asking it to. So it will go into a complete database cleanup node, create a tons of table logs, which is a performance situation I don't think any one of you want to ever be in. So now, because this maintenance DAG has created so many table logs, what happens to the data teams that are using this Airflow instance? This happens. There's this one team who's not able to access diagrams for
66 of their DAGs. And yeah, we don't really know if these entries exist or not in the database because obviously it's a table lock. So what do you do now? So such problems started raising questions against two factors of Airflow 2. First one being security, obviously, because any task can access any secret. And the second one being performance, because a badly written query can lock your database. So these problems could not be fixed easily. So we needed a fundamental change for this. Not a temporary band-aid, but a surgery. So we went and did something radical. So most of our problems are stemming from this blazing red arrow here. So we cut it off completely. Workers can no longer talk to the Airflow metadata database. But wait, tasks need data to run, right? What about connections, variables, XCOMs? There enters the Airflow API server. It's the single, secured, and audited gateway to all your data. But Kaxil, I think I know what everyone's thinking with. Yeah, I'm sure. Like, what about the other components? Specifically, what about the DAG processor and trigger? Don't they need to reach out to the Airflow metadatabase? Yeah, somewhat. It's a bit nuanced. So in Airflow 3, they go through the DAG processor and triggerer, both to go through something called an in-process API server for the code that interacts with the user code. And I'll explain with an example. The DAG processor runs something called a DAG file processor manager. It's a mouthful name, but think of it as a manager that can still interact with the DB, but this manager class does not run or interact with the user code. The class or the component within the DAG processor that interacts with the user code is called DAG file processor process, which is a thing that is responsible to actually parse your DAG files. That will read your DAG files, that will turn it into some metadata to be stored in the database. And it uses the same task SDK code that is utilized by the worker. It utilizes some code to communicate with the API server to get the things it wants. And similar thing for the triggerer. And this was designed intentionally. We wanted to release Airflow 3 really on schedule sooner, but while preserving the security guarantees that we all promised. So our ideal architecture will be when both this DAG processor and triggerer go through the actual API server. That will be our ideal architecture. There is an Airflow improvement proposal for those of you who follow the Airflow dev mailing list. There is already an Airflow improvement proposal in draft called AIP 92, which talks about how we will achieve the same. So anyone interested for more details, please search AIP 92. So here's what this architecture that really gives us. A server component and client component, which Vikram mentioned at the start of the keynote. The server never runs user code. It only works with metadata that is needed to handle scheduling and serving the APIs. The client, on the other hand, that's the task SDK. This is where all the user code runs, whether it is DAG authoring, DAG execution, task execution, or DAG parsing. Now, like one of the key reasons we built Task SDK was to be explicitly and ultra clear about what is the public interface for using Airflow as a library in your DAGs. I'm sure you all used airflow.util something, airflow.models something. That all goes away with Airflow 3. And we tried a lot of things in Airflow 2. We tried adding a lot of documentation around what is the public interface of Airflow. We talked about security models as well. But you know who reads documentation, right? So here's the top takeaway from this talk. Only import stuff from the airflow.sdk namespace. That is the namespace that you should use in your DAG for importing or for running your task and everything. Do not import any other code that is, any other Airflow code that is not in airflow.sdk. If anything breaks, you are on your own. We will probably close the GitHub issue. Now, with the server-client separation, things start getting interesting. It opens up the possibility of independent upgrades of the server component and client component. So imagine if you are a DevOps team maintaining like hundreds of Airflow deployments for like hundreds of teams, 50 teams, whatever, right? In Airflow 2, you will have to coordinate with each one of those teams to say, hey, can we upgrade, please, please? We need to patch this CV. So that is a losing game, or it will stretch for months and months. However, the DAG authors are not idiots. They want to upgrade it, but they're worried if the DAG will break because of some pandas update, some Snowflake provider change. There's a lot of pain. But with Airflow 3, you can upgrade your server component independently. So you as a DevOps person will be able to keep your server on the latest version that includes all the security patches. Your teams, your data teams, they can run whatever task SDK version they want, 1.1, 1.2, as long as the server and client have the same contract, which is the API contract that they both understand. And that is all that matters. Now, that means the DevOps team will own the servers and the data teams own their DAGs. That is the sort of separation that we were aiming for. And because all you need is HTTPS, you can now run your task anywhere, which is exactly what Bosch did. Jens, show us how you are running your Airflow tasks.
Thanks, Kaxil. My name is Jens Scheffler. I'm Airflow committer in PMC, and I'm working for Bosch, and we're using Airflow in a distributed environment. And we had a challenge in our operations, and that was the reason why we came to contribute a big piece, which went into Airflow 3. And that's the so-called Edge Executor. Who have not heard of it will learn it now. Kind of the typical operations is that you have your data center and you have your workers distributed maybe on-prem or in the cloud. Let's assume it's running in the cloud. So as a user, you are outside, usually on firewall access, kind of you're sitting with your PC and you can happily access the environment from the outside and you run your workload. And the workload can be running locally, we call that the local executor, or it can be distributed in your data center with salary workers or Kubernetes executor. We called them in the past remote executors. Now with Airflow 3, and as we said, the task SDK is unbundled, we are able to do a bit more, and that was what we also needed at Bosch. So at Bosch, we have our corporate network that is segregated from the cloud, and on our corporate network, of course, we also have sitting users, and they can work happily and access the Airflow environment via proxy, going out of the corporate proxy, going to the internet, going to the cloud side. But sometimes you have workload that's also sitting in your corporate network. And in the past, that was really hard to bridge. And some people started doing a second deployment on-prem and then bridging different Airflow deployments across the security boundaries. Kind of the Edge Executor now allows you to distribute a worker also on your on-prem side. Or kind of in our case, it was also the way that we had a remote data center or multiple remote data center. It allows you to distribute the Edge Executor, the Edge worker, across your data centers or the places where you need to get your work scheduled to and connect it to your central instance. We called it a bit funny, the very remote execution, so that you can really go abroad. Now with Airflow 3.1 also, we've seen there's a plugin. This now also enables us having a native integration, and it feels like it's belonging to the core, but the Edge Executor now has the first plugin that shows as a first-class sentences how a native integration could look like. So if you deploy the Edge Executor with the most recent version, you have new menu entries for seeing the Edge workers. You can see your kind of every row shows an instance of some Edge deployment. and you can see and schedule your work. And as kind of operations is a bit hard in a distributed environment, it allows you to pause and unpause remote work. You can put it to maintenance. You can remotely shut it down and see how the workload is going. And besides the worker, you also see the jobs that are running on your remote. And that's a demo time. Now we see the jobs not running because they are queued. Seems to be we need to start an edge worker, and I will show you that's really simple. So we see there are 3 workers now, and I maybe need to pop my console. And starting an edge worker is really simple. You just type Airflow edge worker, and I give it a host name. Let's call it Seattle because we are in Seattle now. And you will see in a moment the edge worker starts up. Has a beautiful banner, by the way. And then once it is registered, you see it showing up, and then we'll pull the jobs and start working in a moment. And the UI will live update and show you how the tasks are going. Yeah, so everybody who wants to have a global distributed deployment now can check out with Airflow 3 the Edge Executor, and I can tell happily we are running it since 12 months in production in our side, and we are really happy about it being able to globally distribute. And I'm really proud that a couple of people already contribute from the crowd into the Edge Executor, being a first-class citizen in Airflow. So cutting the remote is one thing, and unfortunately Buğra is not with us. He cannot make it to Seattle, so we have a canned video of Buğra, who is showcasing to us the next thing that is possible if we are cutting out the database, which was not possible before.
Hello, dear guests, Airflow enthusiasts, users, and experts. I'm Buğra Öztürk. I'm from the Airflow team, working as an Apache Airflow committer in Apache Software Foundation and senior data engineer at Molly. Unfortunately, due to some problems, I couldn't attempt the meeting in person. Hope I will be with you next year. The story begins pretty similar to all the others. We saw how our great presenters show us how we lose the direct database access from everything. Well, that includes CLI. Traditional Airflow CLI uses direct database access. For the enterprises, security-aware companies, this is not a starter. With the evolution of security measures in the industry, we needed to update our CLI accordingly. So we brought up Airflow CTL. Airflow CTL is the kubectl for Airflow, 100% API driven, and works from everywhere. As you can see in the diagram, all the components lose their direct database access connection, also the Airflow CTL. And your laptop becomes a secure control center for Airflow instances from anywhere in the world. Okay. Let's deep dive into real-world examples from the console. First, I will demonstrate the login part and Airflow CTL out login with the API URL airflow.airflowsummit.com and username admin. With the admin privileges, I'm entering admin's password. And then I will use Airflow CTL connection list in the table output format. And we have one connection with the task called MySQL. So I will now log in with the username, user, with the user privileges. And of course, I'm entering the user password with the username. And I'm again listing the connections. As you can see, I got forbidden. That means the RBAC in the Airflow API layer worked smoothly. Now I want my admin privileges back to show you like more on the management workflows in the real world examples. I used username, user.works, and listing the jobs now. I will copy paste a couple of commands to keep things faster to show you more. Okay, my jobs are running fine. Processor, triggers, scheduler, their last heartbeat from seconds ago. Listings are variables similar to connections, all the other entities. And please pay attention to the output parameter, which is applied to all of the Airflow commands. Let's create, for example, a variable with variables create, test2, test value 2, because we have the test in place. And I want the output as table, the response, because we are getting a response from the API. And basically, we are outputting that in a pretty format. And let's delete one of them let's delete the first that we show. So, okay, I'm deleting with variables delete with the variable key, and let's list them again. Okay, we only have the variable test2. Let's list them in the table format. Okay, let's move into another topic. Like I selected DAG and I selected the example bash operator. I'm using the DAGs, Airflow CTL DAGs get DAG ID, example bash operator. And as you can see, it's in the pause mode. But I want to trigger a DAG run anyway on this DAG because it will be cute. I'm using the Airflow CTL DAG run trigger and DAG ID and example bash operator, the logical date and run after. And I also added a node triggered from Airflow CTL. Okay, it's showing our background in the response in the JSON format, which is default. Okay, let's now list the diagram with Airflow CTL diagram list. We can also put some filters on it, like state. Okay, what I'm going to do is I will unpause my DAG with the DAG's update. I'm updating the pause Boolean parameter with no is pause. Now our diagram will run, and since it's too fast, I will just list the success one. And you can see they have the same background ID, and you can also use, of course, the table output, and even better with the YAML. Of course, that's not all. This is just the beginning. Airflow CTL completes the vision. Tasks run anywhere, you control from everywhere. And coming soon, leave log streaming, worker management, and even remote debugging.
And with that, I'd actually like to welcome Constance and Vincent to talk about run tasks at any time. Constance, I think you're first.
Hi, everybody. Wow, this is such a crazy turnout. Anyways, my name is Constance Martineau, and I'm a staff product manager at Astronomer. Unlike everybody else on the stage, though, I am not a PMC member or committer, but you may see my name everywhere on GitHub or on Slack because I work primarily with the open source team. So I'm here today to talk about the run tasks at any time portion. So before I get into what the features actually are, I just want to set the context. Traditionally, Airflow pipelines have run on a schedule, so like cron jobs, midnight batches, etc. That's been fine for traditional workflows that for historical analysis purposes, but really that's not how the modern world actually operates. Data is produced continuously. So if we wait until midnight, for example, dashboards and apps are always going to be stale. And we knew we needed to address this in Airflow. The shift in the data industry is really towards data-driven orchestration and responding when events actually happen. So I'm going to start off by just showing you an older style DAG, or two DAGs, I should say. We've got the produce sales daily snapshot DAG and the update executive dashboard DAG. Now, how I would have done this in the past is I'll have my 3 tasks that are going to produce my daily snapshot. So ingest sales events, transform and validate those events, and publish those daily snapshots. In the middle, you can see I have just a little box representing the daily snapshot, but I want to stress that's not in Airflow yet, and it's not something that Airflow actually is aware of. I'll have my other DAG that needs to run after the sales daily snapshot is produced to update my executive dashboard. Now, how I would have done that in the past is I would have taken a sensor. I would have polled for my data source to see when the sales daily snapshot was finally produced. And then I would have run it. The DAG was probably running on a schedule, probably starting at some point at 2 a.m. It'll go on for the entire day, just polling until eventually, like I said, what I need is there, which is very, very inefficient. So in Airflow 3, what we've done is we wanted to make these outputs or these assets a first-class citizen, something that Airflow is aware of. So in this case over here, I still have my 2 DAGs. My published daily snapshot is there. And in Airflow, I can go ahead and I can annotate that saying, hey, this task produced this asset. On the other side over here, you'll notice I no longer need my sensor. I can go ahead and I can have my DAG essentially subscribe to that asset to run anytime that tasks basically says that snapshot's been produced. Meaning I'm using a lot less resources, it's a lot less brittle, and a lot less painful. Now, here are 2 examples that I've got over here. you'll notice what we've also included as part of Airflow 3 is some boilerplate syntax that really revolves around the asset itself. Really, the goal with this is we're trying to make data assets really a true first-class citizen and something that Airflow is aware of. But I want to stress that really this is a matter of personal preference. You can still go ahead and write DAGs or in the same traditional manner using tasks and DAGs and annotating essentially the data asset. Or you can go ahead and use a decorator, which again is really just shorthand to abstract the boilerplate code and have the asset be the focus. Functionally, this is the same thing. It's about preference. So really what I kind of want to stress with this is that the big change with Airflow 3 is that data assets are now first-class citizens in Airflow. And we wanted the asset, or like I said, the thing you're producing, to become the anchor and not just the process. Now, you're probably thinking, wait, the producer DAG though is still cron-based, right? So yeah, that helps a little bit with my dependencies, but it doesn't help with the first DAG. You'd be right. However, we introduced as part of Airflow 3, asset watchers. So asset watchers are a new construct that bridge the external event sources, so message queues like Kafka or SQS, into Airflow. So instead of running that DAG on a timer, you can have that DAG essentially listen for new events in these messaging queues. So the flow really then becomes, for that first DAG, the queue to the watcher that will pull for new events, and then the asset, and then finally the DAG run. So really, I think this fundamental construct is really what makes the shift into event-driven orchestration and really making Airflow a first-class data tool. So again, here's the code, an example. And I just want to stress, it's quite simple using similar constructs that we already have in Airflow 2. We have the trigger that you create. So in this case, it's a message queue trigger. We have the asset watcher that's attached to the asset. And then I went ahead and I could schedule based off of that asset. And then my real-time sales report will go ahead and will be generated every single time there is a new event. You can use this for reporting, but you can also use this for really live actions. Like, let's say every single time a text message comes through, you go ahead and you perform a whole new batch of operations, like sending out some sort of email or some sort of winning. Really, the world is your oyster, but ultimately speaking, these constructs are what bridge the gap between batch orchestration to true event-driven orchestration. So as part of the run tasks at any language, the other thing that we did is inference execution functionality. So in Airflow 2, the issue really is that traditional DAGs have fixed logical dates. This has been great for backfills and again, great for historical analyses, for example, but it's really painful for live processes and for live inference specifically. The issue really is that each DAG run is expected to have a unique date time. And so if I have two events, for example, that come in one after the other, and that really do both need to be executed at the same time, Airflow didn't, until Airflow 3, have a really clean way to do this. So here's the new way. Ultimately, there is a new endpoint that is there that you could go ahead and trigger. You can trigger the DAG run with a null logical date so that that's no longer a consideration. And the DAG, the thing that's triggering that DAG can essentially listen for responses as it's being run. So things like XComps, for example, as they're being generated, will be passed or streamed back to the thing that's listening, really allowing for data app integration, for chatbots. Again, really, the world is your oyster. But really, the thing what you would want to make sure, like I said, to do is that, or with this, is that you want to, that you're going to hit the endpoint, you're going to listen to it, you're going to get the response, and then you can go ahead and continue doing what it is that you were going to be doing. Honestly, this is probably one of my new favorite features from 3.1, and I'm really, really excited to see what people will be doing with it. So without further ado, I'm going to pass it over to Vincent, and he's going to show you a demo of event-driven scheduling so you can see how it actually works in practice.
Thanks. Hi, everyone. My name is Vincent. I'm a Apache Airflow committer, and I'm also a senior software engineer for AWS. and I'm going to show you a demo of event-driven scaling in Airflow 3. So let's start super easy. We're gonna just look at a first example. It's a super DAG. If you can't see the code, don't worry, I'll explain. So this DAG does nothing. It prints hello world. It's not what is interesting here. What is interesting is how this DAG is being scheduled. So this DAG is scheduled based on assets and not based on time, which means this DAG will be triggered whenever the asset receives an event. So far is nothing new compared to Airflow 2. What is new though is there's a new attribute when you build your asset called watchers. And thanks to this attribute, you can associate one or multiple asset watcher to one asset. An asset watcher is basically a trigger with a name. So to summarize this DAG, what this DAG does is you have one trigger that pulls your Kafka topic here, and that is constantly checking whether there's a new message in this Kafka topic. And whenever that happens, whenever a message lands in your Kafka topic, the trigger will fire an event. And thanks to the asset watcher, this event will be then sent to the asset. And because the asset received an event, your DAG is being scheduled. But let's see in action. So here I'm going to be using Kafka CLI to send a message to my Kafka topic. I'm sending test. We're going to have to wait a bit. And I can see that my DAG got executed. If we click on the diagram and look at the task logs, we can actually see the task output, which is here, hello world. But let's try another message. Maybe we got lucky. So I sent another message, which then triggered my DAG a second time. And if I look at the task log again, well, same thing, we can see hello world. If you go to asset events, you can actually see the events received by the assets. And here you can actually see the payload, the message you just sent, basically. So cool, right? Wouldn't be better, because here in this example, we actually didn't use the message. We used the message as notification, but we didn't use the payload. We could have sent any message, the result would have been the same, right? So wouldn't it be better if we could use the payload as part of the DAG? So let's look at a second example. How can we do that? All right, so this DAG is very much identical compared to the first one. The only difference is on the task definition here, we're using a new parameter called triggering asset events. And thanks to this parameter, you can retrieve the payload. Here we're just printing out the payload, but you can obviously do way more than that. You can use it to use your own business logic. But let's see in action. So here, same thing. I'm using Kafka CLI to send a message. I'm sending my payload. We'll wait a bit. My DAG got triggered again. And again, we're going to look at the task logs. And here you can actually see the payload you just sent. So again, using this new parameter, you can access the message you just sent. All right, so now we're going to try something new. We're going to try to pause the DAG and send some messages to the Kafka topic and see what happens. So here I'm closing the DAG. I'm going to have to wait for a few seconds. And while the DAG is being paused, I'm going to be sending some messages to my Kafka topic, and we'll see what happens. So same thing. I'm using Kafka CLI to send messages. I'm sending message. Nothing. Maybe you got lost. Sending new message. Still nothing. Maybe it's because the tag was paused, right? So maybe let's try to unpause it and see what happens. So I just unpause the tag. I wait a bit. And my tag got executed once and twice. So as obvious as it can seem, when the tag is paused, well, it won't pull for any new messages. It will just do nothing. And when you unpause the tag, your tag start pulling again the Kafka topic. And because you sent here 2 messages while the tag was being paused, well, the tag starting to pull those messages and started to be executed. All right, so now let's look at a final example. I mentioned it at the beginning. You can associate one or multiple asset watcher to your assets. So in the final example, we're going to look at an example where you have 2 asset watchers. So this tag is, again, very, very similar to the other one. The only difference here is you have 2 asset watchers. So we still have the one that is listening to the Kafka topic, but we also have one that is listening to a SQS topic. So in summary, this tag will be executed whenever a message lands in your Kafka topic, but as well as when a message lands in your SQS topic. So here, I'm not going to be sending a message to my Kafka topic. I've done 4 times. Sure, you trust me. I'll just be sending a message to my SQS topic. So here, I'm going to be using AWS CLI to send a message to SQS, sending my SQS payload. Message got sent. I'll wait a bit. Hopefully, it's going to work. My tag got executed. And same thing, if you access to the task logs, you can see the payload, which is here different, which makes sense because this one is provided by SQS, which is a JSON. And as part of the JSON, you can actually see the message you just sent. So thank you. That's all I wanted to show you. I'll pass the mic to Constance now.
Thanks a lot, Vincent, for the demo. That was great. And as you could see, even pre-recorded demos are not sometimes immune to technical issues. Anyways, I just want to talk quickly about what's next with assets. So the big thing that we're going to be focusing on in the next few Airflow 3 versions are expanding the data asset model. And so what does that really mean? The first one is partitions and watermarks. So really what we want people to do is data assets are going to evolve. That's just the nature of the job. And we would like people to be able to define assets by day, by hour, by key, so that we can track freshness and history and execute essentially backfills more smartly than we do today. That leads into the second one, which is, again, targeted updates, meaning we want to provide you with the capability of refreshing only what's new or stale instead of reprocessing everything. Asset validations are one that is very near and dear to my heart and is really first-class integration with data quality checks. So that means validation and status surface directly in the UI when data is not conforming to standards that you set. That is something declarative that you'll be able to go ahead and attach to the asset. And that will be able to be used as essentially an orchestration gate for triggering new downstream DAGs. The fourth piece of this is at-a-glance visibility and really rich metadata within the UI. So Vikram talked a little bit about the fact that we've added some first-class views for assets, but there's a lot further that we want to be able to go, including showing you the direct relationships between different assets. And so again, what the goal with this is that you can go ahead, you can look at an asset in Airflow, and at a glance, you should be able to see how fresh the data is, if it's conforming to your data quality checks, and the DAGs that are using that asset. And then last but not least is end-to-end event tracking. So now that we have asset watchers and events really, or data really starting from messaging queues, we want to provide you with a first-class way to be able to track that event from the message queue all the way to the asset, all the way to downstream DAG, so that you can see a full end-to-end coverage of everything, of the entire flow of your data. The net effect of all this is that we really want Airflow to evolve from just scheduling workflows to orchestrating reliable, observable data assets. Thank you. So yeah, up next is Ash with run tasks in any language.
Thanks, Constance. Hi, I'm Ash. Been working on Airflow for, I'm not going to count the years, too many years. I work at Astronomer and I'm also a member of the PMC. Cool. Right. So from Kaxil, Amogh, and Jens, we heard about running tasks anywhere. And with Vincent and Constance, we heard about running them at any time. So I'm going to talk to you about the third pillar, run tasks in any language. So what was our goal here? Fundamentally, at kind of its simplest level, I want more people to use Airflow. It's that simple. You're all here probably because you like writing Python, or at least accept writing Python. There are many people who's like, no, I don't want to do that. I'm just not going to bother, thanks. So we want to let more people work and use Airflow. It's a production-tested, battle-hardened scheduler with hundreds of thousands of hours of development time and countless millions of hours of runtime. So by building tasks in any language, we can enable you to access more data. Maybe you're not always have an easy API or a database connection. Maybe it's tied deeply into your existing, I don't know, Oracle stack. And sorry, by the way, if that's anyone here. But it kind of like gets Airflow access to a richer sense of data and cements Airflow as the world's data orchestrator. So run tasks in any language. We have Python. The first language I am working on, is Golang. Simply because that's the language I know. However, there's a useful property of Go and Java compared to Python, which is they are compiled languages. In Python, it's very easy to import a file at runtime. You can't do that in Go. It's not technically true, but you can't do that in Go. So you need a kind of a different way of building a worker. An important caveat at this stage, I am explicitly talking about tasks in another language. For now, in Airflow 3.1, you still have to write your workflows, your DAG files in Python. Again, as Kaxil mentioned, AIP 92 will go some way to changing that, but for now, tasks in any language, workflows still in Python. So I'm very excited to be able to announce the 1.00 beta of the Go SDK. So as of, well, probably in about an hour after the next talk, when I push it, you can run tasks in Go. So if you're really, really passionate about Airflow, and also you really wanted to write tasks in Go today, you could do it. But this is going to be like, you have to compile it and worry about how you ship it around, and then basically use a bash operator. No one's going to do that. And also, it's a subpar experience. Yes, you are running a Go workflow, a Go task, but you don't have access to connections, to variables, to XCOM, to setting retry signals, all this kind of thing. It's very much a second or fourth class citizen. So our goal here is to build an SDK and an API in Go that feels like Airflow, but in Go. You have the full power of Airflow inside your Go tasks. So that's enough yapping. I'm a developer. Let's talk some code. So I'm going to show you a Polyglot demo. I'll just go through it. So we have here the Edge worker screen that Jens showed us earlier. And I'll just go to the terminal and we'll start up a new worker. So we're going to do Airflow Go run. Let's spell Seattle correctly. It's a hard word to spell. There we go. So we've got a Go worker started up, some logs, and there you go. It's in the UI already. And over here, you can see it is reporting its Go version. So we know that that one's the Go one. You just have to trust me. If we then go over to this DAG I prepared earlier, I'll just start it off in the background while we talk about it. So it's called multi-language DAG. If you're at all familiar with any of the Airflow example DAGs, the tutorial DAGs, this is a slight adaptation to it. So you have these task.stub, which is the new thing we've added as part of 3.1, technically provided with 3.1. The body of these functions is empty. That is not optional, that is a requirement. These must be empty functions. You will get a parser error if not. If you've been around as long as I have, this stub tasks, stub functions may be ringing some bells to RPC or remote procedure call. That is a purpose analogy. If that means nothing to you, don't worry about it. This is how you define your tasks inside a Python workflow in a Python DAG to say, I've got this task, it's got these parameters, don't worry about the body. And then if we go over to what the code looks like, so this is the Go code. Again, don't worry if you can't read it. There'll be more of this in a minute. You kind of a Go function, which returns whatever you want. So in this case, it's a map of some data. And we got a transform function, which just does a simple sub over it. You notice it takes the data. So that's how you can pass XCOM into a task. And it returns, again, another map. This is a direct translation of the Python task flow tutorial DAG into Go. And then the way you consume these functions, call these tasks, is exactly the same as it was for Python task flow. So it all just kind of works naturally. You say it takes some parameters, you call it, it gets it back, you pass it on. This all just kind of works, hopefully how you'd expect it. The goal is there should be zero surprises here. If you know, you still have to know some Python, some Airflow to get these DAGs working, but it should be zero surprises. And as I said, they've already run. So here we go. If we scroll back up, ignore that token. It's short-lived, but it shouldn't be there. There you go. So DAG ID is multi-language. And you got the task ID. So there we go. That's all kind of there. And if we scroll down a little bit, there's the second task. There's transform. So we can now go over to the logs. There's nothing there, but you know, it ran. That's a good start. We now go over to the XCOM tab. There we go. We can see that data that I returned from the Go task. It was just a map of strings, but it got converted to JSON, passed to XCOM automatically. We now go to the downstream task. We can see that it was passed in automatically. So it all gets plumbed through, and there's the thing. I'm not going to do maths on stage. I'm just going to trust the computers better at adding up than me. Not a hard part, to be honest. And then finally, if we go to the load task, there we go. This is a Python task. And right there, we can see it was there. And you can pass data between languages too. This is not just everything must be in Go. This is a true kind of polyglot DAG. So how does this all work? As I mentioned, you need to define a stub task. There needs to be something that exists in the DAG in the mathematical sense, in the graph, that the Airflow knows how to schedule. So what we've got here is task.stub. It is a function. It has parameters. The types don't mean anything. They're just for illumination. But you have a function with parameters, and it must have an empty body. You can't, this is to stop you, like, I'll just put some code there, and then why is it not running? It can't. You can have ... the ellipsis, you can have pass, or you can have a docstring. Anything else, not allowed, will blow up. And then once you've got that, you call it and use it like any other task flow task. It will all just work. So that's the Python side. On the Go side, Go is a compiled language. So you have to build this into a executable. But you can pass some parameters in, you return errors, you can get connections. This is kind of one of the things that was missing from Go, like the bash operator approach. Yeah, you could run some Go code, you could run a binary that was compiled, but you couldn't get access to the connections. Now that we've got this client-server split and an HTTP API, Python is just one client. Writing it in Go, writing it in Java, writing it in Lua, in TypeScript, in whatever else you want is now possible and hopefully quite easy. So you have access to the full power of the Airflow ecosystem and the Airflow orchestration and all that kind of stuff. So what languages do we build next? As I mentioned, we did Go because I know Go. probably going to be working on Java next. I'm not a Java developer, but I can play one on TV. If anyone is a Java developer and knows what a good API should look like, come talk to me. And with that, I will hand it over to Vikram.
Thank you, Ash. So before we get further, one thing I absolutely wanted to say is you've heard from all the dev leads who actually were the leads for the different Airflow improvement proposals, but it took a lot more people than just the people who actually spoke today to make Airflow 3 happen. I did not want to kind of leave without giving a shout out to Elad for all the work which he's done on the providers. There's a huge amount of work to get all the providers released along with all the core changes which we made to Airflow 3. Thank you, Elad. And Jarek and Pavan for all the work on the CI system and the development work, which actually also needed a whole lot of changes that actually fed into a lot of the contributions. As from some of the charts Brent and Pierre showed, the amount of contributions we had were like truly tremendous. And like, it was both amazing and scary at the same time for anyone who's actually kind of had to integrate these many different developer code at the same time. So there's a huge amount of work. Thank you so much, Jarek, Pavan, Rahul on testing, and so many other people who pulled this all together. Also wanted to give a shout out to a lot of the people who actually did work outside of it and making the product ready from a doc standpoint. Mark Lamberti for his demos, Tamara and Kenton for the webinars, and Brianna for pulling all this stuff together as well. Huge amount of stuff. Thank you so much for everybody else. You actually talked about Airflow 3. One of the things which I'm very, very excited about is the traction we have seen in 5 months after we released. April 22nd wasn't all that long ago. We already know of hundreds of enterprise deployments running on Airflow 3. We know of enterprises who have completely upgraded to Airflow 3 as well. And that is something which I'm truly excited by. Couple of things from a contribution standpoint. We actually totally believe in encouraging additional contributions. We believe that Airflow 3 has made a foundation for it to be easier to actually contribute as well. The new React-based UI is a much easier platform to contribute. We have seen a whole bunch of more PRs, as well as about 30 odd people, I think 33, something like that, who actually contributed on the UI itself for 3.1. I would definitely want more people to contribute. With data assets and the common message interface, we've had a lot more people contribute to integrations. As I said, we at Kafka, which Vincent just demoed, was a contribution from somebody in the community. There is Redis, there is Google PubSub, there is Azure, and I know somebody's actually even talking about contributing listeners for like crypto, like and being able to listen to blockchain events and so on and so forth as well. So really look forward to additional contributions. With the Task SDK, as Ash mentioned, we expect contributions in other languages as well, not just Python. Our next language almost certainly is going to be Java, so we're definitely looking for people to contribute in Java. And just as a point of reference, we are about 3,500 contributors right now to Airflow. Last year at the summit, we are about 3,000. So we've added at least one contributor every single day over the last year. Huge shout out to so many people who actually enabled this to happen, who mentor new contributors coming in, Elad, TP, Wei, Jarek, Jed, Kaxil, so many other people who actually enabled this to happen. But one thing for sure, if you're interested in any of these, please do contribute. We love that. And we just welcome new contributions going forward as well. Key thing I want to stress in closing, and hopefully we proved this to you. And the Airflow ecosystem has expanded tremendously. I really look at it as being 5 dimensions. Right? First, the range of personas which we are serving with Airflow today is much larger than what it actually was before. Second, with the inference execution and human-in-the-loop capabilities which we introduced as part of Airflow 3 and 3.1, we believe that Airflow is the natural choice to be the way to deploy AI workflows to production. Third, with the capabilities of what we've done with UI plugins and with the full-fledged API, Airflow can now be used as a platform to build your own applications and services on top of Airflow. Fourth, with the event-driven capabilities which you actually showcase, and with the ability to integrate with the external data systems and with streaming, Airflow provides a complete gamut of batch, ad hoc, and streaming application integration. And fifth, with the ability to integrate into other languages, we actually believe that you can have native integrations into your enterprise applications, whether it is for pulling data or to be able to absorb data like a prediction and keep it in your application and be able to have, because every application is now either a data application or an AI application in some way, shape, or fashion, and Airflow can integrate into any of these. And that's part of the reasons why with these 5 together, we very strongly believe that Airflow is the de facto standard now for data and AI orchestration going forward. Thank you, Maxime, for starting this. We're very excited to be able to take this to this particular level at this point, but we're very, very bullish on how we can actually leverage these capabilities today. If you haven't already upgraded to Airflow 3, we have taken great pains to make this upgrade as easy as possible. There are utilities to be able to convert your DAG code to be compatible to Airflow 3, regardless of how you may be scared by all the changes, like the task SDK and the server and all these changes. All of the DAG changes are actually scriptable through the upgrade scripts which we have. The same thing for Airflow configurations. You should be able to relatively straightforward have an upgrade in place. Please do read the upgrading guide. It will actually be helpful in this particular process. And please do let us know as well if you feel anything is missing. I think there's a definite minority in this group who actually had filled out the survey last year. The 2025 Airflow survey is now open. We do take the survey feedback very seriously. Please take a couple of minutes, fill out the Airflow survey. We actually do absolutely appreciate your feedback and would really appreciate you taking a couple of minutes for this. With that, I'm actually going to turn this over to Jarek. He's got a small announcement to make.
Yes.
Actually, a couple.
Hello, everyone. I have a really great pleasure to tell that, like with all the community work that we have done, we have existing committers, PMC members, and new contributors coming. But also, as Apache Airflow is part of Apache Software Foundation, we have this formal structure of how our contributor ladder looks like. So we have committers and PMC members. And I have a really great pleasure to announce that we just announced and invited, and they approved, they accepted 2 new PMC members, Vincent Beck, who is actually presenting before as a committer. Now he can present as a PMC member. Big round of applause to Vincent for all the work she has done. We also have Wei. So Wei is another PMC member who did a lot of work for Airflow 3 to make it happen in many, many different areas. And we have a new committer, Gwen Mink, who is contributing. That's a really good example of someone who was able to contribute to the UI after all the new changes and the new architecture. And Gwen Mink is a new committer that we just invited, and he accepted. So this is so all this work is possible because of the fantastic community we have, and welcome to all the new PMC members and committers.